Be together. From the starts, Hungry ECOCITIES paths to progress experiments.
A third of the food we eat depends on pollinators, especially bees. They sustain biodiversity, help plants reproduce, and support entire ecosystems. Yet human actions, habitat destruction, pesticide use, and climate-changing emissions are threatening their survival. For millennia, humans have managed hives, domesticating bees to harvest honey and wax. This relationship, however, often treats bees as resources to control rather than understand. What if measurement and technology could help us listen to bees to truly understand their needs? For over 15 years, artists María Castellanos and Alberto Valverde have studied the secret language of plants, creating systems that foster dialogue between humans, non-humans, and machines. Working with bees was a natural evolution, expanding their research from plants to the creatures deeply connected to them. They partnered with Olaya Miel, a family-run ecological beekeeping initiative in Asturias, northern Spain, whose 3 generations of traditional knowledge grounded the experiment in practical reality, and with Beesage, a beekeeping technology company. This collaboration combined artistic vision, generational apiculture knowledge, and advanced sensor technology, developing technology that encourages empathy rather than extraction, and prioritizing understanding over optimization. To achieve this, they needed to build a system that could perceive the hive on its own terms. The experiment brought together multiple technologies into a single, comprehensive monitoring system. Beesage's hive scale measured the weight of the hives to track nectar flows, while their hive nodes recorded internal temperature and humidity. María and Alberto added their Open Environmental Kit, a set of open-source sensors originally designed for citizen science, now adapted for outdoor rural conditions. This setup measured external factors: temperature, humidity, CO2, air quality, and UV radiation. The artists also built custom wind sensors and installed AI-powered cameras to observe bee traffic. A contact microphone captured the vibrations of the hive, focusing on frequencies unique to collective bee behavior, all to detect patterns that could reveal swarm activity and the health of the colony. This went beyond surveillance for productivity. It was an attempt to translate bee experience into something humans could perceive and understand. Analyzing thousands of data points, patterns began to emerge. Artificial intelligence was fundamental in processing large volumes of data, identifying correlations, and generating predictions about hive activity. Bee entry and exit activity proved strongly influenced by environmental conditions. Temperature, light, and UV radiation promote activity, while high humidity reduces it. Acoustic analysis revealed that the hive's sound changes in frequency and continuity before bee movements occur. Higher movement was associated with lower frequency, more continuous buzzing, a predictive signal of the colony's internal state. Hive weight also proved a powerful tool to anticipate nectar flows and detect problems early. From this data, the artists created the interface Be Together, which translates hive rhythms into human-perceptible experiences. Advanced algorithms process thousands of complex data points, transforming them into patterns of light, vibration, sound, and airflow, allowing humans to follow the daily life of the apiary, sensing when bees are active, resting, or when something changes. The device's design combines rigid and soft materials inspired by wild hive architecture, offering a gentler and more responsive technological model. This approach allows non-human experiences to be perceived by humans, making previously invisible needs recognizable, opening new possibilities for understanding and collaborating with other species. The project also explored another form of translation. Non-human nonsense developed an additional honey character for the Council of Foods platform. This digital representative provides a bee's perspective to food system dialogues. The BeeTogether interface proposes a new model of human-bee collaboration. For beekeepers, it provides tools for more attentive and sustainable practices, anticipating problems, understanding seasonal rhythms, and reducing stress on colonies. Beesage's technology can be enriched through this artistic research, supporting not only efficiency but genuine care. The interface and monitoring system remain with Olaya Miel as working tools, with potential to scale to other beekeepers and educational contexts. At the food system level, this transforms how we relate to bees and the need for their preservation as our pollinators. We can work toward reciprocal well-being, where sensitive technology strengthens sustainable beekeeping and ecological resilience. The well-being of bees is the well-being of our own ecosystems. Listening is the first act of care.